5 common mistakes engineering managers make in oil and gas engineering design. In the fast-paced oil and gas industry, engineering managers face intense pressure to maintain schedules, control costs, and ensure quality. However, certain oversights in managing the design process can lead to costly reworks, delays, and quality issues. Below are 5 common mistakes made by engineering managers, with insights into how these impact different engineering disciplines such as mechanical, chemical, electrical, piping, instrumentation, and civil engineering. 1. Not verifying full scope of design changes with each discipline. Lead design changes are a normal part of any engineering project, but not verifying the full scope of changes with every discipline lead can have a ripple effect. Each engineering discipline, whether mechanical, chemical, electrical, or civil, may have unique requirements and standards that can be affected by design alterations. Impact. When discipline leads aren't consulted, changes may overlook critical aspects of equipment, materials, or layout, leading to incompatibilities and rework. Example: if a process change is made by the chemical engineering team without input from the piping or mechanical engineering leads, it might result in incompatible materials or inadequate flow rates, requiring a redesign. 2. Not checking the cost and schedule impact of design changes. Design modifications often affect both the project and timeline, yet engineering managers sometimes overlook this aspect in their rush to implement changes. This can cause unintended cost escalations and delays that cascade across disciplines. Impact. Mechanical, electrical, and civil engineering teams may need to adjust procurement timelines, rework designs, and update schedules, resulting in unforeseen costs. Example: a change in equipment specifications by the mechanical engineering team may require new electrical loads, impacting the electrical design. Failure to assess these impacts could mean higher costs for equipment and increased lead times. 3. Ignoring procurement implications of design changes. Procurement is a critical part of project execution, but failing to consider how design changes impact procurement can lead to delays in materials and equipment delivery. Each engineering discipline typically has specific procurement needs that must align with the updated design. Impact. When procurement is overlooked, critical items like piping materials, control systems, or structural supports might not arrive on time, delaying installation and construction. If a piping engineer changes pipe specifications without updating procurement, contractors may end up waiting for new materials, causing delays in construction and additional costs. Penhasher 4. Rushing to close critical design stages for project schedule. Pushing to close critical stages prematurely, often to keep up with tight project schedules, can lead to oversights and compromise the quality of engineering deliverables. Each discipline requires adequate time to finalize specifications, drawings, and compliance checks. Impact. Electrical, instrumentation, and civil engineering disciplines may end up with incomplete or rushed designs, potentially leading to safety risks and rework. Example: if instrumentation and process control engineers are rushed, critical safety interlocks may be missed, putting the entire system at risk during operation. 5. Not maintaining a proactive, systematic weekly schedule for engineering drawings and documentation. A lack of systematic scheduling can lead to miscommunication, missed deadlines, and inefficient coordination between contractors and engineering teams. Each discipline needs a clear timeline to produce and review design documents. Impact. Without consistent scheduling, mechanical, piping, and civil engineering deliverables may not be aligned, causing delays in construction planning and procurement. Example: if the civil engineering team doesn't receive updated mechanical equipment layouts in time, they might design structural supports that are incompatible, leading to costly rework and schedule impacts. Consequences of these mistakes. The above mistakes can result in several negative outcomes. Unnecessary engineering rework. Contractors and discipline leads may need to redo their work, which could have been avoided with better planning. Unforeseen cost and schedule impacts. Project budgets and timelines suffer due to inadequate coordination and oversight. Redundant deliverables. Rework often means duplicating engineering deliverables, wasting time and resources. Construction delays. Delays in finalizing construction documents and drawings affect the overall construction schedule. Schedule impact on final construction. Lack of integrity in the design phase can lead to delays and increased costs during construction, ultimately affecting the project's success. By addressing these common pitfalls, engineering managers can enhance the efficiency, quality, and success of oil and gas engineering projects. Coordination among disciplines, proactive planning, and thorough change management are key to avoiding these issues and delivering projects on time and within budget. Examples of consequences of mistakes in engineering management. In engineering management for oil and gas, even small mistakes can create a domino effect that impacts schedules, costs, and project quality. Below are detailed examples of common consequences that arise from oversight or mismanagement, illustrating how these errors can lead to rework, unforeseen expenses, and delays. 1. Unnecessary engineering rework. 1. Piping design revisions. A change in process flow is implemented without informing the piping team, leading to an incompatible layout. The entire piping design has to be redone to align with the updated process. Structural support redesigns. New specifications for mechanical equipment aren't communicated to civil engineers, necessitating a complete redesign of foundation and structural supports to handle the updated load. 3. Control system reprogramming. Updates to process parameters are missed by the control team, requiring a full reprogramming of the control systems to reflect these changes. 4. Electrical panel modifications. An increase in electrical load due to last-minute changes requires a complete redesign of electrical panels, which delays installation and adds costs. 5. HVAC system adjustments. Temperature range changes are not conveyed to the HVAC team, leading to HVAC redesigns that include different cooling or heating capacities to match new operational conditions. 2. Unforeseen cost and schedule impacts. 1. Expedited shipping for equipment. Delays in approving pump specifications lead to urgent procurement and expensive expedited shipping to meet installation schedules. 2. Rush order for safety components. An unexpected design adjustment requires a rush order for emergency shutdown systems, incurring higher costs to keep up with timelines. 3. Extended contractor hours. Contractors must work overtime to catch up on delays caused by last-minute design changes, driving up labor expenses. 4. Additional engineering labor. Engineers work additional hours to address unexpected modifications, leading to unplanned costs in engineering labor and stretching project budgets. 5. Vendor penalties. Procurement delays cause vendors to miss their committed delivery schedules, resulting in penalties and further escalating costs. 3. Redundant deliverables. 1. Duplicate process flow diagrams, PFDs. Process engineers need to reissue PFDs after overlooked updates in process conditions, creating unnecessary duplication of documents. 2. Revised piping isometrics. Piping layout modifications are repeatedly issued due to unverified design changes, leading to redundant deliverables and wasted resources. Multiple foundation drawings. Civil engineers release multiple versions of foundation designs due to new equipment specifications that were not properly communicated. 4. Redundant electrical schematics. Changes in equipment power requirements lead to reissued electrical schematics, causing repeated design work and documentation updates. 5. Reworked instrument loop diagrams. Instrumentation engineers reissue loop diagrams after discovering missed updates, creating additional work and documentation that could have been avoided. 4. Construction delays. 1. Delayed piping installations. Piping materials need to be reordered due to specification changes, resulting in delayed installations that impact overall construction timelines. 2. Late civil foundations. Revised equipment loads lead to re-engineering of foundations, pushing back construction schedules as new designs are approved and implemented. 3. Instrument calibration delays. Changes to control system specifications affect instrument calibration schedules, delaying startup timelines and final testing. 4. Electrical system installation setbacks. Late adjustments to electrical loads mean that installation is postponed until the revised designs are ready, impacting the entire project timeline. 5. Slowdown in structural assembly. Structural elements need to be reevaluated and fabricated to match last-minute design alterations, halting ongoing construction and pushing back deadlines. 5. Schedule impact on final construction. 1. Delayed project handover. Final construction stages are pushed back due to earlier design errors, resulting in a delayed handover to operations and potentially missed production targets. 2. Extended commissioning time. Due to rework in control systems, commissioning takes longer as each corrected component must be retested and validated. 3. Prolonged site occupation by contractors. Extended construction timelines due to late design adjustments mean contractors remain on site longer than planned, driving up operational costs. 4. Postponed safety and performance testing. Final safety checks and performance testing are delayed by schedule setbacks, pushing the project's completion date further out. Impact on production schedules. As construction completion is delayed, planned production start dates are postponed, which affects downstream operations and revenue targets. These examples illustrate the far-reaching consequences that can result from missteps in engineering management. In oil and gas projects, thorough communication, careful planning, and meticulous change make these costly issues.